Hello out there, welcome to this mathematics lesson. The topic is fractions. In this video, we'll be looking at simplest form or lowest term, equivalent fractions, improper fractions, and mixed fractions. We start with simplest form or lowest term, where we'll be taking our first problem. Problem 1. Express each of the following in its simplest form. Simplest form is also known as lowest term. So we have A 4 over 6, B 8 over 10, C 18 over 36, and D 63 over 84. So we start with A. Now we are going to create a table, then place the column for numerator and this. To solve this problem, we create a table. This column is for the numerator and this column is for denominator. So we place the numerator here in this column and place the denominator in the denominator's column. Then we look for the highest number that can divide both 4 and 6. So we know 2 can divide both 4 and 6, so we go with 2. 4 divided by 2 gives 2, and 6 divided by 2 gives 3. Since there is no number that can divide both 2 and 3 without remainder other than 1, so we stop here. So we now have our 4 over 6 in the simplest form as 2 over 3. So we go to B. For B, we still create a table, the numerator and denominator. The numerator, which is 8, is here, and the denominator, which is 10, comes here. Again, 2 is the highest number that can divide both 8 and 10. So we go with 2. 8 divided by 2 gives 4. 10 divided by 2 gives 5. So we are at the end of the road. Therefore, the simplest form of 8 over 10 will be numerator 4 and denominator 5. So we have it as 4 over 5. So we go to C part of the problem. For C part of the problem, we still have our table, numerator and denominator. Our numerator is 18. Our denominator is 36. We know that 18 times 2 gives 36. So 18 divide both 18 and 36. 18 divided by 18 gives 1. And 36 divided by 18 gives 2. So the simplest form of 18 over 36 will give us 1 over 2. So we have our answer as 1 over 2. We go to D part of the problem. Again, we create the table. This is numerator, denominator. Numerator here is 63 and denominator here is 84. It might not be immediately easy for us to get the largest number that can divide both 63 and 84. So we can start from smallest number. 63, 6 plus 3 gives 9. Yeah, so it's divisible by 3. 8 plus 4 gives 12, so it's divisible by 3. Therefore we start with 3. 63 divided by 3, we can say 6 divided by 3 gives 2, and 3 divided by 3 gives 1. Then 8 divided by 3 gives 2, remainder 2. So 24 divided by 3 gives 8. So from here now we can see that 7 divides 21 and 28. So we go with 7. 21 divided by 7 gives 3. 28 divided by 7 gives 4. So, and there is no number that can divide both 3 and 4 again without remainder other than 1. So the simplest form of this fraction will be 3 over 4. So we've done justice to problem 4, which is basically on simplest form and lowest term. So here we are going to equivalent fractions. That's where we'll be taking our second problem. So problem 2, give 3 equivalent fractions for each of the following fractions: A 2 over 3, B 1 over 7, C 8 over 21, and D 10 over 11. So we start from A part of the problem. To get 3 equivalent fractions to 2 over 3, what we do is whatever we multiply by the numerator, we also multiply by the denominator. So we start from 2. So 2 times 2 gives 4, and 3 times 2 gives 6. So the first equivalent fraction here is 4 over 6. Again, we multiply numerator by 3 and multiply the denominator by 3. 2 times 3 gives 6, and 3 times 3 gives 9. So the second equivalent fraction of 2 over 3 is 6 over 9. So we multiply by 2 to give us the first one, 3. So to get the third equivalent fraction, we multiply by 4. So 2 times 4 gives 8, and 3 times 4 gives 12. So we have the third equivalent fraction of 2 over 3 as 8 over 12. So we've done justice to problem 2a. We go to problem 2b. The same way, we multiply the numerator and denominator by 2 to get the first equivalent fraction. So 1 times 2 gives 2, 7 times 2 gives 14. So 2 over 14 is the first equivalent fraction of 1 over 7. Then to get the second equivalent fraction, we multiply by 3. So the numerator times 3 will give us 3, and 7 times 3 gives 21, which gives the second equivalent fraction of 1 over 7. And for the third equivalent fraction, we shall multiply by 4. 1 times 4 gives 4, and 7 times 4 gives 28. So these are the 3 equivalent fractions of 1 over 7. Then we go to problem 2c. I have 8 over 21. Also, we multiply both numerator and denominator by 2 to get the first equivalent fraction. 8 times 2 gives 16. 21 times 2 gives 42. So we have 16 over 42 as the first equivalent fraction of 8 over 21. To get the second equivalent fraction, we multiply both numerator and denominator by 3. So 8 times 3 gives 24, and 21 times 3, 1 times 3, that will give us 63. So we have it as 24 over 63, which is the second equivalent fraction of 8 over 21. And the third equivalent fraction, we multiply by 4. So 8 times 4 gives 32. 21 times 4 gives 84. So we have 32 over 84 as the third equivalent fraction of 8 over 21. We go to problem 2d. Problem 2d again, we multiply the numerator by 2, which gives 20, and the denominator by the same 2, which gives 22. And 20 over 22 gives the first equivalent fraction of 10 over 11. Then the second equivalent fraction we multiply by 3. This is 30 over 33, which gives the second equivalent fraction of 10 over 11. Also, to get the third one, we multiply by 4. 10 times 4 gives 40 over 44. These are the equivalent fractions of 10 over 11. This is the end of the solution to problem 2, which is on equivalent fractions. So we go to the next set of problem, which is on improper fractions, where we take our problem 3 from. For problem 3, express each of the following fractions as improper fraction. The method of expressing a mixed fraction as improper fraction is, first we multiply the whole number by the denominator, then add the numerator. This is the whole number part of these mixed fractions, and this is the denominator and this is the numerator. So if we multiply the whole number part by the denominator, then add the numerator, the denominator will still remain the same in the new fraction you are forming. And in that new fraction, the numerator is greater than the denominator. That is why we call it improper fraction. So we start with problem A. For problem 3A, I have 1 whole number 1 over 4. So the 1 there is the whole number. We have the 1 multiplied by the denominator, which is 4, and plus numerator plus 1. 1 times 4 gives 4. 4 plus 1 gives 5. So in the new fraction, which is the improper fraction of 1 whole number 1 over 4, the numerator is 5 and the denominator will still be maintained as 4. That is the solution of problem 3A. We go to problem 3B. In problem 3B, the whole number is 13. So we have 13 multiplied by the denominator, that is multiplied by 5, plus the numerator plus 3. 13 times 5 gives 65. 65 plus 3 gives 68. So the numerator of the improper fraction we are going to form here is 68 over 5. The denominator is always maintained if you are expressing a mixed fraction as improper fraction. So we go to problem C. For C, I have 4 whole number 1 over 15. The 4 whole number is there, multiplied by the denominator, which is 15, then plus the numerator, which gives 1. So here 4 times 15 is 60 plus 1, which gives 61. That will form the numerator of the improper fraction, and the denominator is still 15. So we have done justice to problem 3C. We go to 3D. For 3D, I have 5 whole number 10 over 13, and the whole number is 5 multiplied by the denominator, which is 13, plus the numerator, which is 10. So 5 times 13 gives 65. 65 plus 10 gives 75. So the numerator is 75 over 13. So we have done justice to problem 3D, and that is the end of solution to problem 3. So we go to the next problem, and the next problem is on mixed fractions, and from the mixed fractions we will be taking problem 4. Problem 4, express each of the following fractions as mixed fraction. These are improper fractions, so we want to express them as mixed fraction, and this is the reverse of the problem we just solved in problem 3. So here, starting from A, what we do is we are going to be dividing the numerator by 3, take the quotient as whole number, and the remainder as the numerator, but the denominator will still be maintained. So we have 8 inside here, and we have 3. 8 divided by 3 gives 2. Can only go twice, so we say 2 times 3, which gives 6. 8 minus 6 gives 2, and here this is our whole number, and this is going to be our new numerator, while this 3 will still be maintained as denominator, so that 8 over 3 will be equal to 2 whole number 2 over 3. This is the mixed fraction of the improper fraction 8 over 3. So we go to B part of the problem. For B, I have 9 over 2, then dividing the denominator, then dividing the numerator by 2, we have 9 divided by 2. 9 divided by 2 gives 4. We say 4 times 2 gives 8. Then we subtract 9 minus 8 gives 1. We say this is the whole number part of the mixed fraction, and this is the numerator, while the denominator will still remain as 2. So that 9 over 2 will be equal to 4 whole number 1 over 2, which gives the mixed fractions to 9 over 2. Then we go to C part of the problem. So for problem C, we have 38 over 7. Then we divide 38 divided by 7. 38 divided by 7 goes 5 times. So we now say 5 times 7, which gives 35. We subtract 8 minus 5 gives 3. 3 minus 3 gives 0. So this is still the whole number, and this is now the numerator. So that 38 over 7 as mixed fraction will be 5 whole number 3 over 7. So we go to D part of the problem. For D part of the problem, I have 79 over 15. So dividing 79 by 15, 79 15, that's 75, and it's going to be 5. So 79 divided by 15 gives 5. So we have 5 times 15 gives 75. Then 79 minus 75 will give us 4. This is the whole number part, and this is the numerator of the new fraction, so that this will still be maintained as denominator. So 79 over 15 gives 5 whole number 4 over 15. That is the end of solution to problem 4, and this is the end of this video. I hope you enjoyed this video. Check the description section to this video on our YouTube channel for our next video on fractions. Until we come your way again, goodbye.